Here in problem 4.25, they're asking you to graph the conic section. In this problem, since I see that only one of my terms is squared, that lets me know that it's going to be a parabola. So since only y is squared, it's a parabola. If only x was squared, I would still know that it's a parabola. So once I have decided that, I need to isolate the non-square term. Isolate non-square term. And in that case, or in this case, that is x. So to isolate x, I'm going to add both of these, or move both of these terms to the other side. X equals 2 minus y squared. So now that I have isolated my non-square term, I can make a table. X and y. Now, since y is a function of x here, or I'm sorry, since x is a function of y here, I'm going to plug in y values. So this is the same as saying x of y equals 2 minus y squared. So we're going to plug in y values to get our outputs. So the ones I want to plug in, -2, -1, 0, 1, 2, are always a pretty good amount of points to plug in. So for x, I'm plugging in -2 here. So 2 minus -2 squared, x equals 2 minus -2 squared, which equals -2. X equals 2 minus -1 squared, which is 1. X equals 2 minus 0 squared, which is 2. X equals 2 minus 1 squared, which is 1. And x equals 2 minus 2 squared, which is -2. So when I'm graphing a parabola, it's much easier to plug in points to get some output values. So now I can plot these points. Now I'm still going to plot them x, y. -2, -2 is here. 1, -1 is here. 2, 0 is here. 1, 1 is here. And -2, 2 is up here. And we know it's going to be a parabola. And we can see our vertex is at the point 2, 0. So when we have a parabolic term or a parabolic conic section, we can tell because only one term is squared. Isolate that non-square term, make a table, and plot the points.